And thanks for joining me. This is the Adobe Fikemba, and here we're going to continue. The last time we were talking about measurements and units, and we talked about measurement has to do with the finding of the size and the amount of a quantity and expressing it as a what? A number of a defined unit. And then we also talk about comparing what the unmeasured with the what? With the calibrated thing. A thing that is to be measured is compared with a thing that is already calibrated, or a thing that is already measured with a known reference. So I gave you examples like, look at this. This is a meter rule now. It's already calibrated, meaning it has a known reference. Those numbers are the calibrations. Okay, so but look at this particular item now. This item, there's nothing. I want to know the length of this item. If I'm going to know the length of this item, I will bring that what? That thing that is to be compared with this that is not measured. But this is already calibrated. Calibration means a measured material with a known reference. So we've known that this is from this meter rule is from zero centimeter to 30 centimeter. That's what this one is. And 0 to 30 centimeter. And the implication is that if I'm going to measure this with this, what am I trying to do? I'm comparing. So in measurement, there is always what? Comparison with a thing that is already calibrated, or with a thing that is already measured with a known reference. That's why you see those numbers there. That's the reference. And with a what? A thing that is not calibrated, that is not measured. So you want to know what this one actually is. Then I'll place the ruler in between to check. And with that, I've been able to measure the what? The length of this what? Material. I also want you to know that in measurement, not only we have comparison, there is also, measurement cannot be complete without a statement of uncertainty. Measurement cannot be complete without a statement of uncertainty. What does that mean? It means that this is what gives us the confidence that we can depend on that material when we are using that particular calibrated material to measure something that is not known. So the implication here, the statement of uncertainty will begin to tell us features that can be involved while taking that measurement. So what are the uncertainties that can arise during measurement? Number one, we have what we call random effect. Random effect is one of those uncertainties that can happen, random effect. And number two, we have what we call systematic effect. Systematic effect. Now, when you talk about random effect, this is a kind of effect that arises during measurement. Okay? A kind of effect that is influenced by the environment. Influenced by the environment. Let me demonstrate. For example, if I'm going to measure this thing now, and mistakenly, by mistake, I put it this way. Look at it. I put it this way. Instead of taking this, starting it from the zero mark, and now put it at the center, and now begin to take the measurement. That's a random effect. And if I'm going to correct this random effect, I need to do what we call use statistical techniques to correct random effect in a measurement or after the measurement. Now, for example, look at this measuring cylinder now, for example. Okay, look at this measuring cylinder. Are you with me? If, for example, now, I want to do titration, for example, in chemistry. I want to titrate. And at the end of the day, I did not avoid error due to parallax. I did not avoid error due to parallax. Maybe the chemical, the acid, was somewhere here, around 10 mil, for example. Then me, I was not taking here, 9.5. Now, if I'm going to correct this kind of error, you understand? You know that if I shake the retort stand holding the burette, the acid inside this burette will be doing what? The acid inside the burette will be doing what? It will be shaking. And you know, once it shakes, the fluid inside will fluctuate, and then it can affect your reading. If you take reading at that time, that's a random effect. That's a good example of what we call environmental factor. That's something caused that error or caused that thing to happen. So that is a random effect when in relation to measurement. It will not force me to go and take 9.5. But if I want to correct it, all I need to do is to take this thing maybe like 3, 4, or 5 times, depending on what I want. And then if I do it 3 or 4 times, at the end of the day, whatever I get, I will add all of them and divide it by 3 if I did it 3 times, or 4 if I did it 4 times. So that time you are adding all and dividing by 3. What are you doing? You are taking their mean. And when you apply mean in such a calculation, you are trying to do what? Correct the random effect of that measurement you are taking concerning that thing. So you can see that the random effect is an environmental factor effect, something that can influence within the environment, factors that can affect it. But when you look at systematic effect, this systematic effect is that kind of effect that comes with the what? That comes with that calibrated material. Do you understand what I'm saying now? That's why you see some material, beside that material, they will always write something either plus or minus a particular number. Okay, take for instance, look at this measuring cylinder. I want you to look at this measuring cylinder. This is a 1000 mil measuring cylinder. Can you see it now? Look at, this is 1000. Are you seeing it now? 1000 mil. Look at somewhere they wrote plus or minus. Can you see it now? 10 mil. Are you seeing it now? Plus or minus 10 mil. That thing you see there is to be taken as part of the result during your what? Your measurement. Are you seeing it now? That plus or 10 mil now is describing the what? Systematic effect. This is the effect that comes with the what? With the calibrated material used to measure the unknown. So when you are going to be taking reading, since you have plus or minus 10 mil, it means that if your reading is, let's say, 50 originally, you are either, depending on what you are looking for, going to add 10 to 50 or subtract 10 from 50. You see it now? So that is how you can correct that word, systematic effect. Already that statement of certainty in this case is already known that there is plus or minus 10 error that can happen using that instrument. So when you do that, you either add or subtract. So that is a good example of what? Systematic effect. In our next video, we're going to be looking at measurements of other quantities as the case may be. I'd like you to share, subscribe, and thank you for joining me. If there's anything you don't understand, I'd like you to put it on the comment section and we are going to answer it together. Thank you.